Hello dear students, welcome to chemistry session. Very good morning to everybody. Let us in condition we are taking this is the ligand field theory and crystal field theory assumption. First of all, याचे assumption काय आहे हे बघूया. This theory was discovered by scientist Bethe and scientist what Blake. So these two scientists were discovered by this theory in 1930. So okay, so what is the assumption? अब इसका main assumption क्या था, है ना? Ligand field theory का assumption क्या था? So what is the first? It explain. This is most important. Optical spectra. Optical spectra यानी काय केला? Explain केला. Optical spectra. So that is optical spectra is nothing but what a color spectra, color property. Okay. Again it explain what a magnetic property. आता magnetic property explain करत असताना इथं सगळ्यात महत्त्वाचं काय झालं? With the help of spectrochemical series. इसने क्या किया? Spectrochemical series का use किया. So what is the spectrochemical series? So that is what hydroxy, halogen, water, pyridine, ammonia, ethylene diamide, nitrogen, cyanide, carbonate. So that is what. So these are the stronger ligand, and this considered stronger ligand. This is moderate ligand, and this is what a weaker ligand. So here halogen, fluorine, chlorine, bromine, iodine. तो यहाँ पे ये जो लिगेंड है ये वीकर लिगेंड है ना. These are the weaker ligand. So this weaker ligand is considered a high spin complex. So it is also explain this property on the basis of high spin complex and low spin complex. High spin complex and low spin complex. So it is used with the help of the transition metal. So this one of the assumption, this one is of the another assumption. So this is another most important assumption is that when ligand approaches to, there is presence of the ligand which is approaches to what central metal atom approaches to central metal atom, then splitting is takes place. Very important. Then what? Splitting takes place. Splitting pattern. You can say splitting pattern takes place. So how is the splitting pattern and how the ligand approaches to the central metal atom? देखो यहाँ पे splitting pattern कैसे introduce हुआ, कैसा generate हुआ? So that how if you have this metal atom is central, this is the ligands. This is the ligand. So the ligands having tendency to what approaches this to donate the electron to the metal atom. It is nothing but what and ligand are approaches to the metal atoms at that time. Here is most important. This what at that time it is a degeneracy. So that is what a degeneracy. What is most important? Degeneracy is a takes place. So then electrostatic attraction takes place between the metal and ligand atom. Then what there is a formation of the splitting or the two sublevel is created. That is what 5 orbital here. So that is nothing but dx1, dx and dy short. So this is on the loops, between the loops. This is between the loops. Again on the loops. Dx square minus y square and d third square. So this is on the loops. There is a two patterns takes place, two sublevel. So that is what a 1, 2 and this is what a 1, 2, 3. This is nothing but T2J and this is nothing but AG. So these types on the basis of when this ligand are approaches to the central metal atom, at that time splitting takes place between the between order ligand and metals. This is between of d orbital or f orbital. This is for the d orbitals. So there is a splitting pattern it takes place. Here the value is for you can take this for the this is nothing but 0 points. So this is nothing but 6.0 and 0 it is minus and is plus 1. So that is nothing but 0.04 dq. So this is a dq and this one is dq. So total value is nothing but delta 0. Or you can say this is nothing but 10 dq. So that is what a 10 dq value. So these are the 10 dq values for the tetrahedral complexes. This is nothing but for the tetrahedral complexes. Because of the 4 ligand are approaches to the central metal atom and the energy level is takes place. The splitting pattern is takes place. Is and T2 is here. So that is nothing but total value is what a 10 dq. So that is for the tetrahedral complexes. Whenever for what is the octahedral complexes? The metal atoms which are having the 6 ligand. These 6 ligand are approaches to the central metal atom. This ligand 1, ligand 2, ligand 3, ligand 4, ligand 5, ligand 6. It's 1, 2, 3, 4, 5 and 6. whenever these 6 ligands are approaches to the central metal atom, and then what about this, the energy level is takes place, this sub energy, what formation of this is the two sub orbitals, 1 2 3 orbit here and 1 2 orbit here. It is what a EG orbit, and this is for the T2G orbit. It is the formation of this is nothing but 10 dq. There is generation of the Kriya, this is the nothing but 2 energy level. This is the T2G and it is what EG. So this is what it is nothing but triply. इसको क्या कहते हैं? ट्रिपली, और इसको क्या कहते हैं? डबली. So it is doubly degenerate. You can say degeneration. So degenerate, and this is nothing but triply degenerate. So that triply degenerate and this is doubly degenerate. For what? This is for the octahedral. Why octahedral? Because the 6 ligands are approaches to the central metal atom. Then what about? There the splitting pattern takes place. This again what? This value is minus 0.4 dq and this is plus 0.6 dq, or what is the 10 dq. This was the splitting pattern for the octahedral complexes. So again, if the complexes are in the NiCN4 2 negative, so this one of the drawback from the crystal fit theory. What I mean, this is NiCN4. This is one of the drawback from the crystal fit theory 2 negative. So this is what again what you can take this what this is the CO. You can see copper is there. CuNH3 taken 4 times. This is what 2 positive is there. So this is two complexes. What is the splitting pattern of these two complexes? What is the splitting pattern of these two complexes? If that is nothing but d orbit is there. I mean that's 1 2 3 4, and this one is a 4. So that is nothing but what energy level orbitals. Though this created what this formation of this again what 2 degenerate level is here. So what is that 2 degenerate levels? These are 2 suborbital is here. So again what this is what we are going to the formation of this is again this one is for the square planar complexes. This is nothing but what dx square minus y square, and this is for the dz square. So here dxy and this what dxz and dyz. So this is a pattern for this what square planar complexes. Here 3 orbit and this was 2 orbit. This is for the EG level and this is for the T2G level. So these are the total value again what 10 dq for this splitting pattern for the NiCN4 2 negative and CuNH3 for 2 positive. This splitting pattern is takes place for the square planar complexes. Okay, so this is again what properties the ligand consider as the point charges. So that is having this is nothing but a negative charge. This ligand having this a negative charge or what neutral ions. Negative charge or neutral ion. So these are the two main important points here. One of the important points is there after splitting patterns, and you can take this one of the assumption of the LFT or the CFT. So another assumption, it explains this is the color property, it explains the magnetic property, paramagnetic, diamagnetic. The magnetic property is explained on the basis of the spectrochemical series. Just we have been explained here. So on the basis of again the temperature factor, the magnetic property is explained on the basis of the spectrochemical series as well as temperature factor. Again it explains this is the color property, optical spectra is there. Again it explains this is the bonding. So this is most important bond between the ligand and metals. It is nothing but ionic bonding. This is the purely purely ionic. This is a purely ionic or what electrostatic attraction. This is electrostatic. This electrostatic attraction of the purely ionic bonding is takes place between the metal and ligand. So that is nothing but what the ligands having tendency to ligand. Most important is that it is explained at a splitting pattern phenomenon. This is a ligand field theorem. You can see this is a ligand field CFAC. So that is what is the CFAC phenomenon. You can say this CFAC. What is the CFAC for the? This is nothing but a crystal field stabilization energy. So that is nothing but the total number of electron. This is the number of electron in what T2G. Number of electron in T2G into what 0.6. Can say this is minus 0.4 dq for the tetrahedral. Okay, so for the octahedral is here. Okay, plus what number of electron in EG here into 6.0 delta Q. So that is nothing but what this is the crystal field stabilization energy. So this is for the crystal field stabilization energy CFAC for the octahedral. For the tetrahedral, you can take this one a T2G. Here is EG and here is a T2G. So this is also explained by the ligand field theory. So these are the assumption or the postulate of ligand field theory. First of all, we explain this theory. this theory is explained by scientist Bethe and Lake. It explains this is the that is most important. Electrostatic field is there, degeneracy level is there. So that degeneracy is nothing but same energy of atomic orbitals. That is the nothing but this is the degeneracy. Okay. Next it explains this is the most ionic bonding or this purely electrostatic attraction between the metal and ligands. The next one, it explains the optical spectrum. Optical spectra, this is nothing but color spectra. It explains the color magnetic property. This is most important. Explain the magnetic property on the basis of spectrochemical series, on the basis of low spin complex, high spin complex, inner sphere, outer sphere. Again, what? It explains the magnetic property on the basis of the temperature factor, temperature dependent. Again, it explains the ligand approaches to the central metal atoms, octahedral complexes, splitting pattern from octahedral complexes, and the splitting pattern from the tetrahedral complexes as well as square planar complexes. There is a different energy levels, there is a different splitting pattern phenomenon for the octahedral, tetrahedral as well as square planar complexes. Here again what is explained, this is one of the one of the important point. This is CFT. So that explains this is the crystal field stabilization energy, how to calculate the crystal field stabilization energy, and it explains the point ligand act as a point charges at a negative as well as a neutral species. The ligands having the neutral as well negative having tendency it is nothing but act as a point charges is there, and the finally test this is nothing but what crystal field stabilization energy. The stabilization, the factor of the stabilization it explained. So these are the assumption, or you can say a postulate or assumption of ligand field theory or crystal field theory.